one, and then I'm going to put it on the low rung, and that'll be more of an old river.
Okay.
But you'll see when water, of course, first it's going to get it's going to have to get all the material wet first. So it's going to take some time.
Can we build our own stream channel?
No.
It will do it itself. It will.
It'll eventually.
Yeah, because it will create that. You can turn it up a bit.
Flashlight.
And it might take some time. I probably should have gotten it saturated beforehand. Because this might take some time.
Just let it go.
Yeah, it'll eventually do it, won't
There
it?
it goes.
It will.
There it goes. Path of least resistance.
Right, and it will go down and say this is a steeper slope. So what kind of erosion would we see? Would we see horizontal or vertical erosion with this steeper slope?
Vertical.
Who remembers
Vertical,
that?
right.
Vertical.
I got corrected. I said both. I said both.
I said both.
So we
See, 'cause
see-
it would be both. We'd be cut down and sideways.
Vertical erosion and down cutting. So it's called down cutting. And again, it's going to have to, as it goes down, you'll be able to see.
Look at that.
Well, it's just saying.
It's like when you're driving down
That
the
is
road,
really
Because
interesting.
it's not saturated yet.
where you see these little cuts in the road.
And this is part of the water cycle. Like you can even think about this as instead of an actual river, which has already got a channel in it, you could think of this as infiltration and part of the water cycle as well. They've got some runoff, it's got to infiltrate. This is all dry sand, so it's got to infiltrate first. We'll probably use this material on Wednesday for soil classification. Use that Gigundo binder I showed you guys today.
That's what.
It's like watching paint dry.
I know. Go faster.
Well, you can see where it's carrying some material and it's depositing it now.
Oh, my.
Right there, and see what's depositing off to the side.
That's kind of cool.
Look at that. Isn't that neat?
You never played with mud balls when you were a kid?
I know.
It's been a while. Huh.
Again, I probably should have gotten this saturated beforehand. This would be a faster demo if I did, but I had never done
It's a new river.
this demo in a long time.
Well, you know, river took millions of years, so we got all day.
Yeah.
It's still a speed
Hour.
process.
And of course, this is a stream table that that Brandon built for our class as a demo table. And they have big stream tables like this, and you can actually do all sorts of really cool lab activities or exploration. For example, you can see all this material here where, trying to predict where particular materials would go downriver. You create mathematical equations with that.
Sweet split too.
Well, what's cool is you see the water is turning moisture way before the creek ever gets there, because you see it's actually growing.
That's cool.
Thank you. And today is just a demo, but yeah, we could use this in future times with actually using it as part of the lab. We could take pollutants and put them up here and try to predict where they would end up downstream.
It never flows any further than where it's saturated.
It needs to infiltrate first. And it's still, right at this point, still just creating, well, here's another question. What shape would you see, is this a U-shaped or V-shaped channel? It's creating the channel after it's infiltrated.
It's a U.
After it's infiltrated, huh?
Saturating,
It would be a V-shaped, right?
Yeah.
Yeah.
and then
V-shaped channel.
Oh, I thought
the
it was
lighter
gonna
sediments
be
are traveling.
Because it's down cutting, so since it's down cutting, it's creating that V-shaped channel going down. It keeps cutting down, cutting down, until it gets to the bottom. And we're gonna see more of a U-shaped channel when we bring it down, and hopefully when we do the meanders, you'll be able to
Oh.
see that. You won't see too many meanders here,
amazing.
because it's a little bit on the steeper side. See, it's going straight down. I tried to make it as flat as I could,
Yeah.
but it's not perfectly flat, so it's going in different directions here. If I had brought this up to the top wrong, it would go. It wouldn't even get it. It wouldn't have as much lateral, even infiltration, probably.
Pretty soon it's gonna go into, it's gonna hit the dam.
Yep. And what is it going to create down here at the bottom?
A pool.
Lake.
A pool, a lake, or a reservoir, but what would it, where would all the sediments are going to end up down there creating a delta?
A delta.
Yeah, that's the delta at the bottom.
So is the delta distributed more evenly across the,
Well, on this one it won't. The sediments are going to go into, well, yeah, it will over time, but this one you're going to see it's all going to end up in one spot because it's a young, youthful stream.
Did you talk about the river types?
We did already.
Because I would call this a braided river.
Well, braided river, yeah, this could actually, well, when we get down to an older river, braided river would be a ton of sediment just being, yeah, we could actually, when it gets to the older one, this is a lot of sediment, not a lot of shrubbery and stuff, so you're going to end up with, when we put it down a rung, the old age river, lower gradient, will have a lot more meanders. And a braided river, we might see a braided river in the next one, and that's where you get like an ensured at the Resurrection River with all the different channels. And we could end up with a braided river with the older.
Glacial rivers usually look like that.
Mm-hmm.
Because they're
because the amount of sediment, it's just all sediment keeps falling out, keeps falling out, keeps falling out, and it doesn't.
respectively the slope is really small on those U-shaped valleys. Valleys. The other one in Alaska would be the Tanana.
Yes, yeah, up in Fairbanks there's a ton, and out Matanuska, I don't know
Yeah.
the name of the river that comes out of the Matanuska there. Is that the Tanana?
No.
Matanuska.
What's that one that's one-sided Sutton as you're going up?
That's, yeah, the one that's on the Matanuska Glacier.
Yeah,
That's
that one's just way flat and there's just a couple little small.
rocks everywhere.
Yeah. A lot of gravel.
Kind of looks like this,
Oh.
except
Landslide.
there it is. It does look like a landslide. Look, we've got a landslide. It is. It's a mudslide.
It is a mudslide. Wow.
That's something even I did not expect. The whole thing coming down.
River's
it
gone.
infiltrated it so well that it's all moving.
Yeah.
A little trickle of water.
Because
Ooh, I
there's no
could talk
shrubbery.
about
Thing is turning into a river.
Yeah.
This is
Talk about
it's
silt.
created.
Oh.
No more river.
Oh.
Yep.
Did
Yeah,
you
it's
expect
V-shaped,
that?
all right?
You didn't expect that.
No, I didn't expect
Oh.
the whole thing to come down. And of course, the materials, depending on the materials that are in here,
She made the thing
could
rough and
cause
slick.
Smooth, yeah,
What?
you could have lined it with sandpaper or something, so
Yeah.
it was not smooth.
or if it was all sand, this is sand that came from the maintenance department.
Yeah.
And so it's a combination of who knows what kind of materials. If we put pure sand in here, it might react differently than say pure silt,
'Cause
pure
this has
clay.
been washed. This has been washed. I'm assuming. If
Oh.
it came from the pit, the sand has been into the wash.
It's been washed, but look at